Hello and welcome to GameDevBox. I'm Aryan, and if you are here to learn game development with Unity, you are in the right place. Now before we dive in, there are already some amazing beginner tutorials out there from YouTubers like CodeMonkey and Brakis.
Getting started creating video games can be really scary, and it can be hard to know where to begin.
They have covered the basics with incredible detail, so why add another beginner tutorial? Here's the thing, this isn't your typical beginner tutorial. Instead of guiding you through building a game from start to finish, we are taking a different approach. We are going to really get to know the Unity engine, exploring its features and tools from top to bottom. Now what won't you find in this video? Well, we are not going to create a game from scratch, and we won't be delving too deeply into every single tool or scripting feature. Let's face it, that could take forever. But here's why it's worth sticking around. By the end of this video, you will have an understanding of how game development works. Imagine you want to do something in Unity that you have never seen before. You don't even know what to search for, or better to say, you don't search for. And this is what happens to me. I tell the story later. That's where I come in. I will give you the names, pointers and basics, and then you can search on the internet and find the great tutorials for it. We will spend the first hour getting started with Unity and C#, and then the next 3 hours will be all about exploring Unity's features, tools and some scripting tips. Should you watch this before other beginner tutorials? It's a good question. Honestly, it depends on your learning style. Some might prefer to start with more standard tutorials, while others might want to jump straight into the deep end. And one more thing, I want to apologize if you noticed my voice changing throughout the video. Unfortunately, my microphone decided to give up halfway through recording. My voice right now is recorded with new one, but the first hour is recorded by the old microphone. By the way, this video took me about a month to make. I have realized that making longer videos isn't my thing. So if my voice sounds a bit different at times, that's probably why. I believe using the Unity engine is preferable to other engines. First of all, I choose the Unity engine back then because Unreal couldn't run on my system due to system requirements, and actually now I'm happy with this decision. I love C# and I love working in Unity. But the reason for you can be accessibility. Unity offers a user-friendly interface and comprehensive documentation, and cross-platform compatibility. Unity almost supports all available platforms, even Apple Vision Pro. Large community and resources. Unity has a vast community of developers and artists who contribute to forums, tutorials and assets store. You can create AAA game graphics with the Unity nowadays. Performance is getting better every day, especially with the dot system. And most importantly, C# makes it much easier to work with. After a couple of years, you won't regret learning C#, believe me. You can do everything with C#, and Microsoft improves this language every day. And Unity is constantly evolving with regular updates and new features. Unity 6, which we will look at the end of the video, is really a big deal. Lastly, making the game with Unity is very scalable. So as I said, it's a really great way to enter the game development field and find jobs. Before anything, we should know about the basic game concept, the essential elements that form the fundamental of any game development process. Game concept could be fundamentals, scripting, 3D assets or 2D assets, building in in-game environments, animation, graphics, audio, physics, analysis, user interface, and more. The most important one is fundamentals. Fundamentals encompass a wide range of concepts, including your knowledge about the game engine, how colliders function, implementing the input system, creating various effects, understanding 3D principles, and game design theory. It also includes mechanics, player engagement, and the overall structure of games. These fundamentals are extremely important because if you are unsure of how to achieve your desired goal, you may lose your way, leading to increased development time. Let me share my experience with you. When I was creating my first game with my friend a couple of years ago, we had to generate numerous bubbles whenever the character hit the enemy. We ended up needing around 150 or 300 bubbles for this effect. My friend and I manually created all of them in Photoshop, and then we animated them using Adobe Animate. However, we were completely unaware of Unity's particle effect system. As a result, it took us several weeks to create these effects. Eventually, we discovered that we could achieve the same result in just 30 minutes using Unity's built-in tools. Our lack of knowledge about the fundamentals of the engine and tools forced us to abandon that project. Unfortunately, the game was never completed. This video is exactly what I want to introduce, each tool in the Unity engine, so you can carefully choose them. Visit the Unity website and download Unity Hub. Once downloaded, install Unity Hub and launch it. Upon first launch, Unity Hub will prompt you to sign in with your Unity account. In the top left corner, you will see the version of Unity Hub. Below that, you can sign out, access account settings, or manage your licenses and organization. In Preferences, you can configure project location, content install location, software them, and language. In the License tab, you can add your license. Unity offers a free personal license, so be sure to activate it before downloading any Unity version. In the Advanced tab, you can switch between Unity Hub versions. Click on the Install tab on the left. Here you will see the installed Unity versions. For example, I have Unity 2022.3.21 LTS. LTS stands for Long-Term Support. Click Install Editor and choose a recommend version. Unity recommends using the LTS version for production and other version for testing and learning. Make sure to check Install Visual Studio. If you already have Visual Studio, ensure game development with Unity is installed via the Visual Studio installer. If you intend to build your game for Android or other platforms, click on the respective modules. Additional languages and documentation can be found in the respective sections. In the Learn tab, you will find excellent tutorials from Unity to enhance your skills. You can also seek help or find answers in the Community tab. In the Project tab, you will see available projects. You can add projects from your computer or Unity Cloud. To create a new project, click New Project. Unity offers various templates, but for now let's start with an empty project. The built-in template represents a completely empty project. We will talk about URP and HDRP later on. Choose a name and location for your project, and select the organization associated with your account. Turn on Connect to Unity Cloud and Unity Version Control when you want to work on a project. Otherwise, just leave them off. Finally, click Create Project and wait a few minutes to proceed. Unity is divided into two main parts: the Unity editor, where you develop your game, and the Unity player, which runs your built exported game. The game object is the most important concept in the Unity editor. Every object in your game is a game object, from characters and collectible items to lights, cameras, and special effects. However, a game object can't do anything on its own. You need to give it properties before it can become a character, an environment, or a special effect. They do not accomplish much in themselves, but they act as containers for components, which implement the functionality. Also, remember that a game object always has a transform component attached, and it is not possible to remove this. The transform component determines the position, rotation, and scale of each object in the scene. Unity's interface is customizable and user-friendly. Most useful and important windows are Hierarchy, Project, Inspector, Scene, and Game. The Hierarchy window displays every game object in a scene, such as camera, lights, or models. If you add a game object to your project in a scene view, it will be listed in the hierarchy. If you delete a game object from the scene, it will no longer be listed. For example, let's create a cube. Click on the plus button or right click and go to 3D object and select cube. It will create a cube at the 0 position in our wall. The inspector is where you will find and configure detailed information about game objects. When you select a game object in the scene view or the hierarchy, you will see its components in the inspector. Components are the functional pieces of every game object. Components contain properties that you can edit to define the behavior of a game object. For example, this cube has 3 components: transform, mesh filter, and mesh renderer. This main camera game object has transform, camera, and audio listener component. In the center of the default Unity editor layout is the scene view. This is your interactive window into the world you are creating. You will use this scene view to manipulate objects and view them from various angles. With a right click and WASD, you can move in this world. With the middle of the mouse, you can set the speed of moving, and with the shift button, you can speed up the movement. With the view tool, Q shortcut, you can pan the camera around. With the move tool, W shortcut, if you select a game object, you can move them in the scene view. The 3 arrows represent blue as the Z-axis or forward, yellow as Y-axis or up, and red as X-axis or right. If you drag each arrow and move them, you can see in transform component the position is changing. If you left click on the name of the game object in hierarchy, it will let you change the game object name. Also, you can change the name from top of the inspector. The next tool is rotate, which will rotate the selected object. The rotation is measured in degrees. A tip for rotation is maybe you hear them differently. Z called roll, Y called yaw, and X called pitch. The scale tool is for changing the size of the selected game object in X, Y, and Z axis. If you drag the center of it, it will scale from every axis. Also, you can change each parameters in transform component. If you want to reset the game object, go to top right of the transform component and click the reset button. If you enable constraint proportions, all axes in a scale will change in the same number. The Rec tool also works like the Scale tool, but it's more like a 2D control. Transform tool is move, rotate, scale activated at the same time. At the top right of the scene, you can set the view to orthographic or perspective. This displays the scene view camera's current orientation and allows you to change the viewing angle and projection mode. The game view is rendered from the camera in your application. It shows how the final built application looks. You need to use one or more cameras to control what the player sees when they are using your application. With pressing Ctrl, Shift and F, the object will be set in the position of your scene view. So as you see, I use this to set my camera position. Also, if you want to focus on a game object, press the F button. You can create as many scenes as you want to. Just go to File and create a new scene. If you select empty, it won't be any game object in your scene. You can add them with a right click in the hierarchy. We want a camera and a sun, which is called directional light. At the top of all your objects, the scene name is displayed. If there is a star in front of it, it indicates that the scene has not been saved. You can save it by clicking on File, then Save or Save As, or simply by pressing Ctrl S. Pick a name and a location to save the current scene. The project window displays all of the files related to your project and is the main way you can navigate and find assets and other project files in your application. For instance, I can import my 3D model. With dragging and dropping the 3D model from project to scene view, it will create the game object in hierarchy. Note that this game object is created in the sample scene, not other scenes. In the bottom right of the project window, there is a slider. You can change the size of the assets. On the right of the project window, there are two main folders, Assets and Packages. Packages are Unity's default package, and also you can download packages and load them onto that project. If you delete packages, Unity will import them again. The only way is to delete them through the package manifest or PackageManager, which we will look at it later. The Assets folder is the root folder. All of our music, models, animations, codes, and other things should be imported into the Assets folder. You can right click in the project window, go to Create, and you can create a folder, a Csharp script, an animation, a shader, or even a scene and other things. If you click Show in Explorer, it will open the project folders. Each asset you import to your project creates a meta file. If you delete meta files, Unity will import them again and create a meta files for them. The tool handle changes the handle position. For example, the center is the center of all selected objects. The pivot can be created in 3D software. For example, my character pivot is at the bottom of my model. So in Unity, if you set the tool handle to pivot, the position, rotation, and even scale will change from that part. Also, there is a way to create a custom pivot. Create an empty game object and drag other object to this object. This will make the parent and child. The parent position represents as a pivot and handler for all children. The tool handle rotation can be in global or local mode. Global will keep the X, Y, and Z. For example, if I rotate this model, you can see my move arrows are not changing with the model because it is in global. But if I want to change with model, I should put it in local mode. Then the Z axis always in front of my model. The next tool is the visibility of the grid. You can change it as you like. The next tool is grid snapping, which only activates when we set the handle rotation to global. You can snap along the grids. The snap increment tool is exactly like grid snapping, but it only works if you hold the control button. And then you can set how much you want to change the movement or rotation of the axis. The next one is shading mode. You can set it to a wireframe or shaded wireframe. We will talk about this later. The next one is for 2D. 2D doesn't have the Z or depth axis. It's only X and Y. The next one will disable light for the scene view, mute or unmute the audio, and disable or enable effects in the scene view. In hierarchy, you can hide the objects. This hide only works in scene view, not in game view. The next tool is the scene camera, which does have camera properties. We will learn about them later. And the last one is gizmos. Gizmos are icons for game objects. For example, I can create an icon for a cube by going to the inspector and adding an icon to it. You can disable gizmos or change the properties. Gizmos only show icons or lines in the scene view. You can see them in your exported game. Now let's go to game view. The first button can be set to game and simulator. The simulator is used when you want to see your game on different devices. Next, we can change the resolution. We can set it to HD or Full HD, or even create our own resolution. A lower resolution aspect ratio is only for Unity editor, to gain more performance and decrease GPU works. VSync syncs the game's frame rate to the refresh rate of the monitor. This only works in game view, not in build. If you set to play focused when you press the play button, this game view won't be maximized. For maximizing the game view, set that to play maximized. We will talk about frame debugger later. The stats will show us information about the game running. For example, I'm getting 700 frames per second. We will talk about all of these later. You can also enable gizmos in the game view. As I said before, the windows are customizable. You can close them and open them through Windows and General, and then select the tabs. The shortcuts are written in front of them. Also, you can move them and place them anywhere. After creating your tabs, you can save it to use in other projects too. Go to Layout and save the layout or use these pre-made layouts. There is a search button in the project window where you can find the assets. There is a lock button in the inspector or any other windows that will lock the window. If you lock the cube inspector and select other game objects, the inspector will remain as it was and it won't change. You can sign in or sign out of your account here. Manage Unity services and Unity version controller, which we will look at it later. This button will show us the history. We can undo to any previous actions. We can put this tab in our project too. There is another search button that will look at the name we gave it to it in project, hierarchy or any other windows to find it. Navigate to the Package Manager window located in Unity's top menu, Window Package Manager, to view available packages and feature sets for installation or those already installed in your project. The Unity Registry section displays Unity technology packages. In project, list the packages currently in your project. My Assets is where you can find assets downloaded from the Unity Assets Store. Built-in comprises Unity tools that you can disable if needed. For this tutorial, I will need to showcase both Unity 2D and 3D. To do so, I will download the 2D complete package, which contains several 2D packages. Also, if you create a 2D project, these packages will be automatically downloaded by default. Let's start by creating an empty game object, then click on Add Component and search for Mesh Filter. The Mesh Filter component holds a reference to a 3D mesh. Now if I click on this small button here, it will display all the meshes in my project. I will pick the sphere mesh. But as you can see, nothing's happened in the scene view. Why can't we see the sphere? That's because the mesh filter always works with a mesh renderer component on the same game object. The mesh renderer renders the mesh that the mesh filter references. But why is our sphere pink now? This is because each 3D model needs at least one material. Otherwise, it will appear pink or show as missing material. To fix this, I can either assign one of these materials or create my own material by going to the project window, right click, create and choose material. Let's pick a name. We will learn about materials later on, but for now let's assign this material to the mesh renderer. In the material properties, we have the option to change the color. Create an empty game object and add a sprite renderer. The component renders the sprite and controls how it visually appears in a scene for both 2D and 3D projects. A sprite is a 2D image. The Kenny website is a good place to download some sprites for our game. Import image. Click on the image and set the texture type to Sprite. Then apply the changes. Now we can use this sprite in Sprite Renderer. We can change the color and flip it in the X and Y axis. If you have already imported the 2D packages from the previous section, go to GameObject, 2D Object, Sprite. Unity automatically creates a GameObject with the Sprite Renderer component attached. A collider defines the shape of the game object for the purposes of physical collisions, enabling it to interact with other elements. You can add a collider through the Add Component option, choosing from options such as a sphere, a box, a capsule, or for 2D purposes, the 2D colliders. Mesh colliders are heavier due to their complexity, as they depend on your 3D mesh. If we want to say which one has better performance, a sphere collider has the best performance than capsule and box. Moving on to RigidBody, it allows game objects to be recognized by the physics engine, enabling special interactions. We can see here that it gives the object mass of 1, a drag of 0, and an angular drag of 0.05. Changes the center of mass to a different part of the mesh. Skip this tensor because it's a little advanced. And also we can tell whether to use gravity or not. If we turn on is kinematic, this game object cannot be moved. Let's create a plane. The plane has a mesh collider. Let's delete this mesh collider and see what happens when I press the play button. My cube just goes through the plane and ignores it. This is because we don't have a collider for the plane. Now let's add the mesh collider again and press the play button. The cube hit the plane as we expected. Let's see what it looks like if it doesn't have gravity. We would expect to just kind of float, and that's kind of behavior that we get. But if something were to hit this cube, it would just kind of float away as it's in space, because we don't have gravity. Let's create some collision to fall and hit this cube. We need RigidBody for this game object because we need to move and fall. The sphere should fall down and bounce off the cube. But if we enable the is kinematic, it won't move. Let's explore a constraint components by searching for constraint to display all available options. A constraint component links the position, rotation, or scale of a game object to another game object. A constrainted game object moves, rotates, or scales like the game object it is linked to. We don't have time to look at all of them. Let's just take a look at the rotation and lookout constraint to understand how it works. By adding the rotation constraint to a cube and creating another cube named target, We can use this target as a source in the rotation constraint settings. Remember to activate it by pressing active or 0. As the target's rotation changes, the cube will adjust accordingly. The cube's rotation is influenced by the target. You can adjust the weight to determine how much the target rotation affects the cube. For instance, setting it to a 0.5 applies half of the target's rotation to the cube. Now let's examine another constraint called Lookout constraint. In this setup, the cube will automatically orient itself to face the target. As you can see, the z-axis or forward direction of the cube aligns with the target's position. This feature is useful when your character needs to focus on an enemy or object in the game. Feel free to explore other constraints as well. They are all straightforward and easy to understand. Use preferences to customize the behavior of the Unity editor. Go to Edit, Preferences. General preferences allow you to customize the overall behavior while working in Unity. You typically don't need to change anything, as the default setup is usually sufficient. However, here you can adjust the Unity DEM to either light or dark. You can go to Unity documentation to see what each of these settings do. Use the external tools preferences to set up external applications for scripting, working with images, and source control. So for example, I have set up Visual Studio and I can also choose Visual Studio Code or Rider. GI Cache. The global animation system uses a cache on each computer to store intermediate files used to pre-compute real-time global illumination. All projects on the computer share the cache. We will talk about global illumination in the lighting section. When you press the play button, if you observe the Unity editor closely, you will notice that the color of windows changes. This indicates that you have entered play mode, and any modifications made during this mode won't be saved. So if I move this object to a different location and then exit play mode, the cube will return to its original position. It's important to avoid making changes during play mode. However, if you must make adjustments, you can copy the component and after exiting play mode, simply paste it back. You can customize the color of the play mode tint by navigating to Preferences, then Colors, and finding the play mode tint option. How can we create our components? As we have seen in previous sections, all of them were built-in components that we can't modify their scripts. They are all pre-made. To create our own custom components, we need to start by creating our first C# script. We can do this by right-clicking in the project window, selecting Create, then C# script. After naming the script, we can simply drag it onto any game object in the scene. The script we have created will function just like a built-in component. We can open up the script and write our own functionalities. As I mentioned at the beginning, I will cover the basics of C#, perhaps with a hint for those who don't know anything. But that might not be enough, so I highly recommend at least taking a beginner C# course before continuing. The first section of your script is your libraries. These contain functions and pre-made codes that make coding much easier. The Unity library, for example, contains all Unity functionalities and is essential for most of the C# script you will create in your project. Next, you will see your class, where you will write your code. The name of the class should be match exactly what you have set up for the script in the project window. The myFirst class is inherited from MonoBehavior, which means everything has been set up for the MonoBehavior class you have access to. MonoBehavior is a base class that many Unity scripts derive from. MonoBehaviors always exist as a component of a GameObject. If you delete this MonoBehavior, you can't attach the script to any GameObject, and those already attached will give a warning that they can't read this script. Start and update are default functions Unity has implemented for us. Start is called before the first frame of your game. In the body, we can write print. Print is a default function that prints the message into the Unity console. So in parentheses, write a string defined with double quotation marks and then write hello world. Also remember that at the end of each line you have to put semicolon. This is a C# syntax. Save the script by pressing Ctrl and S and return to Unity. Make sure this script is attached to a GameObject. Then hit the play button. You will see Hello World printed in the Console tab. The Console tab is where you can print or see warnings and errors. The update function will be called once per frame. So if I put this hello world inside this update function and save it and then press the play button, you will see hello world printed many times, once each frame. The best way to start learning C# is to open Visual Studio and create a console app .NET framework. Go to View and select Solution Explorer or open it with Ctrl-Alt-L. Solution Explorer shows you the project configuration and libraries. And the program.cs is the script that you can modify. Also, if you right-click on the project and go to Add and then New Item, you can create another C# class. All of your code should be written in the body of classes. Also, in the console app, you run your code through this main function. In C#, a field stores a piece of data within an object. It acts like a variable and may have a different value for each instance of a type. The C# syntax is like this. The access modifier, then specifies the type, then the name, and set the value or just leave it empty. Every C# statement ends with a semicolon. Members of a class can be marked with access modifier, including public and private. A public member can be accessed by other classes. A private member can only be accessed by code in the same class. By default, if you don't write the access modifiers, it will be marked as private. In C#, there are different types of variables, defined with different keywords. For example, int stores the integers, whole numbers without decimals, such as 15 or -15. Floating point types are float, double, and decimal. Stores the floating point numbers with decimals, such as 19.99 or -19.99. Char stores the single characters such as A or B. Char values are surrounded by single quotes. A string stores the text such as hello world. String values are surrounded by double quotes. Bool stores the values with two states, true or false. A data type holds a data value within its memory space. It means the variables of these data types directly contain values. If we create an int x and set the value to 3 and int y to 5 and then int c with the sum of these two variables, always the data put from left to right. So x plus y is 8 and 8 will be put in the c variable. Unlike value types, a reference type doesn't store its value directly. Instead, it stores the address where the value is being stored. In other words, a reference type contains a pointer to another memory location that holds the data. The following image shows how the system allocates the memory for the above string variable. These are reference type: string, arrays, class, and delegate. For example, I can create another class and name it a student, and in program just get a reference of it. New keyword used to initialize the class in the heap. When you pass a reference type variable from one to another, it doesn't create a new copy. Instead, it passes the variable's address. For instance, if we change the value of a variable in one of them, the other one changes too. In the example, we pass the student object std1 to the change reference type method. Here it actually passed the memory address of std1. Thus, when the change reference type method changes a student name, it is actually changing a student name of std1 object, because std1 and std2 are both pointing to the same address in memory. A string is a reference type, but it is immutable. It means once we assign the value, it cannot be changed. If we change a string value, then the compiler creates a new string object in the memory and points a variable to the new memory location. The default value of a reference type variable is null when they are not initialized. Null means not referring to any object. A value type variable cannot be null because it holds value, not a memory address. Csharp 2 introduced nullable types in which you can assign a null to a value type variable. Using system means that we can use classes from the system namespace. Namespace is used to organize your code, and it is container for classes and other namespaces. Class is container for data and methods, which brings functionality to your game. Every line of code that runs in C# must be inside a class. The curly braces mark the beginning and the end of a block of a code. Console is a class of the system namespace, which has a writeLine method that is used to output or print a text. If you are not using system library, you would have to write system.console.writeLine to print the text. C# is a case sensitive. My class with uppercase M and my class with lowercase have different meaning. Remember that a variable's name always starts with a character, not numbers and symbols. Comments can be used to explain C# code and to make it more readable. Any text between double slash and the end of the line is ignored by C#, will not be executed. Multi-line comments start with / asterisk and ends with asterisk /. Fields and methods inside the classes are often referred to as class members. In C#, static means something which cannot be instantiated. You cannot create an object of a static class and cannot access a static members using an object. You don't need an instance to access a static member. In C#, a const keyword is used to declare constant fields and constant local. Once the constant field is assigned a value, it cannot be changed. There are some rules between programmers to write clean code. that every other program can read it. Camel case. The first letter of the word is always in a small letter, and after that, each word starts with a capital letter. Pascal case. The first letter of every word is in capital letter. You can read more about rules on internet. Typecasting is when you assign a value of one data type to another type. Implicit casting. Automatically converting a smaller type to a larger type size. Explicit casting. Manually converting a larger type to a smaller size type. Arithmetic operators are used to perform common mathematical operations. Assignment operators are used to assign values to variables. In the example, we use the assignment operator equal to assign the value 10 to a variable called x. Comparison operators are used to compare two values or variables. This is important in programming because it helps us to find answers and make decisions. The return value of a comparison is either true or false. These values are known as Boolean values. As with comparison operators, you can also test for true or false values with logical operators. Logical operators are used to determine the logic between variables or values. The Csharp math class has many methods that allows you to perform mathematical tasks on numbers. Arrays are used to store multiple values in a single variable. To declare an array, define the variable type with square brackets. We have now a variable that holds an array of strings. To insert the values into it, place the values in comma-separated list inside the curly braces. To create an array of integers, you could write: you access an array element by referring to the index number. This statement accesses the value of the first element in cars. To find out how many elements an array has, use the length property. In C# there are different ways to create an array. The if, else, and switch statements select a statement to execute from many possible paths based on the value of an expression. C# has the following conditional statement. Use if to specify a block of code to be executed if a specified condition is true, and use else to specify a block of code to be executed if the same condition is false, and use else if to specify a new conditional to test if the first condition is false. Use the switch statement to select one code block to be executed. Loops can execute a block of code as long as a specified condition is reached. Loops are handy because they save time, reduce errors, and they make code more readable. The while loop loops through a block of code as long as a specified condition is true. When you know exactly how many times you want to loop through a block of code, use the for loop instead of a while loop. Statement 1 is executed one time before the execution of the code block. Statement 2 defines the condition for executing the code block. Statement 3 is executed every time after the code block has been executed. The example will print the numbers 0 to 5. Statement 1 sets a variable before the loop starts, int I equals to 0. Statement 2 defines the condition for the loop to run. I must be less than 6. If the condition is true, the loop will start over again. If it is false, the loop will end. Statement 3 increases the value I++ each time the code block in the loop has been executed. You can loop through the array elements with the for loop and use the length property to specify how many times the loop should run. There is also a for each loop, which is used exclusively to loop through elements in an array. The break statement can be used to jump out of the loop. The continue statement breaks one iteration in the loop. A method is a block of code that only runs when it is called. You can pass data, known as parameters, into a method. Methods are used to perform certain actions, and they are also known as functions. Why use methods? To reuse code, define the code once, and use it many times. A method is defined with the name of the method, followed by parentheses. C# provides some predefined methods, which you already are familiar with, such as main. But you can also create your own methods to perform certain actions. Void means that this method does not have a return value. To call a method, write the method's name followed by two parentheses and a semicolon. Information can be passed to methods as parameters. Parameters act as variables inside the method. They are specified after the method name, inside the parentheses. You can add as many parameters as you want. Just separate them with comma. You can also use a default parameter value by using the equals. If you want the method to return a value, you can use a data type, such as int or a string, instead of void, and use the return keyword inside the method. With method overloading, multiple methods can have the same name with different parameters. OOP stands for Object-Oriented Programming. Procedural programming is about writing procedures or methods that perform operations on the data, while object-oriented programming is about creating objects that contain both data and methods. Object-oriented programming has several advantages over procedural programming. OOP is faster and easier to execute. OOP provides a clear structure for the programs, and OOP helps to keep the C# code dry, don't repeat yourself, and makes the code easier to maintain, modify, and debug. OOP makes it possible to create full reusable applications with less code and shorter development time. Classes and objects are the two main aspects of object-oriented programming. Look at the following illustration to see the difference between class and objects. So a class is template for objects, and an object is an instance of a class. A constructor is a special method that is used to initialize objects. The advantages of constructor is that it is called when an object of class is created. It can be used to set initial values for fields. Constructors can also take parameters, which is used to initialize fields. In C# you can use read-only keyword to declare a read-only variable. This read-only keyword shows that you can assign the variable only when you declare a variable or in a constructor of the same class. The meaning of encapsulation is to make sure that sensitive data is hidden from users. To achieve this, you must declare fields, variables as private, and provide public get and set methods through properties to access and update the value of a private field. You learned from the previous chapter that private variables can only be accessed within the same class. However, sometimes we need to access them, and it can be done with properties. The get method returns the value of the variable name, and the set method assigns a value to the name variable. The value keyword represents the value we assign to the property. C# also provides a way to use a shorthand automatic properties where you do not have to define the field for the property, and you only have to write get and set inside the property. In C#, it is possible to inherit fields and methods from one class to another. We group the inheritance concept into two categories: derived class, child, the class that inherits from another class, and base class, parent, the class being inherited. Use the colon symbol. In the example, the car class, child, inherits the fields and methods from the vehicle class, parent. C# doesn't support multiple inheritance. If you don't want other classes to inherit from a class, use the sealed keyword. Polymorphism means many forms, and it occurs when we have many classes that are related to each other by inheritance. Inheritance let us inherit fields and methods from another class. Polymorphism uses those methods to perform different tasks. This allows us to perform a single action in different ways. The virtual keyword in C# allows subclasses to override methods of the base class. This is crucial for enabling polymorphism in object-oriented programming. For example, this method can be overridden by any class that it inherits. It is useful for code reusability, reuse fields and methods of an existing class when you create a new class. Data abstraction is the process of hiding certain details and showing only essential information to the user. Abstraction can be achieved with either abstract class or interfaces. The abstract keyword is used for classes and methods. Abstract class is a restricted class that cannot be used to create objects. To access it, it must be inherited from another class. Abstract method can only be used in abstracted class, and it does not have a body. The body is provided by the derived class. An abstract class can have both abstract and regular methods. Another way to achieve abstraction in C# is with interfaces. An interface is completely abstract class, which can only contain abstract methods and properties with empty bodies. To access the interface methods, the interface must be implemented, kinda like inherited by another class. To implement an interface, use the colon symbol, just like with inheritance. The body of the interface method is provided by the implement class. Note that you do not have to use the override keyword when implementing an interface. C# does not support multiple inheritance. A class can only inherit from one base class. However, it can be achieved with interfaces because the class can implement multiple interfaces. An enum is a special class that represents a group of constants, unchangeable, read-only variables. To create an enum, use the enum keyword instead of class or interface, and separate the enum items with a comma. You can access enum items with a dot syntax. By default, the first item of an enum has the value of 0. The second has the values 1, and so on. Enum is a byte data type. To get the integer value from an item, you must explicitly convert the item to an int or use a byte data type. Byte variables can store integer values between 0 and 255. That's enough for the basics of C#. I hope you enjoy, and don't worry if you don't fully understand it, you will learn more during the video. Also, no one reaches mastery of something in one day. Just give it some time. Also, I recommend seeing these two websites. They have good tutorials for C#. Alright, from here the video takes a bit of turn. I'm just gonna run through the tools and features, showing you what they are all about. But I won't be going too deep into any of them because we don't want this video to go on forever. Still, it should give you a solid overview. Now that we have made this far, let's break down the game process. First up, we import assets into the Unity editor. These assets can be anything from visual to audio elements, 3D models, texture, a sprite, sound effects, or music. Next, we create content using the Unity editor with those assets. This is where we bring our ideas to life. Then we build our app or game file, and optionally it can have content bundles. After that, we distribute the build files so that our user can access them, whether it's through a publisher or an app store. Lastly, we load further updates as necessary at runtime, depending on our user's behavior. To temporarily remove a game object from your scene, you can mark the game object as inactive. To deactivate a game object through the script, use the setActive method. GameObject means the object our script is attached to. To see if an object is active or inactive, check the active self property. If you deactivate a game object, the script and all other components will be disabled. Get a reference to a component of type T on the specified game object. That T can be any script or built-in component. For example, let's get the collider of this game object and store it in a public box collider. And then let's change the size of the collider in the start function. This way you can get all the components you need, access them through the script and change their values. For example, I create another script and have a field on it. I can get the reference and change the health to 50. If I attach the other script to the same object of my first script, I will use the get component to get the reference, but if it's in another game object, there are multi ways to do it. For example, you can set the variable public and get the component in the inspector. Or use the find object of type and it will try to find the component in your scene. If you want to get multiple components and store them in an array, you can just use find objects by type or get components. Get components in children or parent will find the type of the component you gave to it in children or parent. So here I get all the colliders in children, and in the loop I will print them and change their size. Also, there is a try-get component which is the best to use when you are not sure if the component you are searching exists or not. If not, the game will give you a null error, so in case you don't get errors, use try-get component. Unity does have many default functions, like these two start and update functions. So if you want to see all of them in Visual Studio, press Ctrl, Shift and M. This will open a window that contains all of the built-in functions you can set to generate method comments. Unity calls awake when an enabled script instance is being loaded. It's called before start function. We use fixed update for physics calculation. For instance, if we grab the rigid body and tweak its velocity or apply a force to it. You can adjust the frame rate in project settings, time, fixed timestamp. Late update is called every frame after the update function is executed. This is handy when we need to calculate something at the beginning of the frame and then use it later in the frame. For example, we always use a late update to handle the camera. So if the camera needs to adjust its position and rotation to follow a character. We use late update to ensure our character has moved in the frame before the camera starts to follow it. On Animator IK and on Animator Move are for animations, let's skip them. On Application Pause will call when comes out of the application, but still it runs in the background. And on Application Focus calls when we open a background application again. On Application Quit is called when we close the program. On became invisible is called when the renderer is no longer visible by any camera. And on became visible is called when the renderer becomes visible by any camera. On before transform parent change is called before you change the parent of an object. On collision inter, on collision exist, and on collision stay are called when this collider has began touching or stopped touching another collider. Also, there are on-trigger inter, on-trigger exist, and on-trigger stay, which are called when two collider marks as triggers collide with each other. Remember, always need one rigid body for one of the game objects to collision occurs. On destroy will call when we destroy the game object. On enable and on disable calls for when we activate or deactivate our game object. On draw gizmos for drawing lines and gizmos for editor or runtime. GUI system is an entirely separate feature from Unity's UI system, mainly intended as a tool for programmers. It is driven by calls to the onGUI function on any script which implements it. The onMouse down function is called when the user presses the mouse button while hovering over a collider or UI element. Similarly, the other onMouse functions act exactly as their names. Skip these for now as they are not relevant to this video. However, you can search for more information about them if you are interested. The onValidates function is called when the script is loaded in the editor. The reset function is called when we manually reset the function in the Unity editor. These built-in functions are incredibly important, and you will find yourself using them frequently in your games. A tag is a reference word that you can assign to one or more game objects. For example, you might define player tags for player-controlled characters and an enemy tag for non-player controller characters. You could define items the player can collect in a scene with a collectible tag. A game object can only have one tag assigned to it. For example, you can check the tag with the compare tag in onTriggerInter to verify if the collided object is what we expected. If it's not, you can skip the code. Layers are a tool that allows you to separate game objects in your scene. You can use layers through the UI and with scripts to control how game objects interact with each other within your scene. For example, you can disable collision detection between two layers by deselecting them in the project settings under physics and removing the specific layer interactions. We will explore more examples of layers in other parts of the video. The raycast function casts the ray from the origin point in the given direction for a maximum distance of max distance, checking against all colliders in the scene. It returns true if the ray intersects with a collider, otherwise false. We can store data in a variable such as raycast hit by using the out keyword before the variable name. Optionally, we can provide a layer mask to filter out colliders in which we are not interested in generating collisions. We can utilize debug.drawLines or debug.drawRay to visualize the raycast gizmos. It's important to note that raycast will not detect colliders for which the raycast origin is inside the collider. This functionality is particularly useful for detecting objects in scenes or for implementing features in first-person shooter games where shooting mechanics often rely on raycasting. There are also other types of cast like box cast, sphere cast, or capsule cast, which function similarly to raycasting but with different casting shapes. A camera is a device through which players view the world. A ScreenToWorldPoint transforms a point from the screen space into world space. A screen space is defined in pixels. The bottom left of the screen is 0 and 0, while the top right is a pixel width and pixel height. The Z position is in world units from the camera. This function returns a vector tree. Vector tree is a data type that contains x, y, and z coordinates. Additionally, there are functions like viewport to world point, world to screen point, and even a screen point to ray. For example, if I cast a ray from the camera to the world and it hits something, I can create an object in that position. Coroutines provide an excellent way of easily managing things that need to happen after a delay or over time. Coroutines work by encapsulating methods that have a return type of enumerator. Enumerator is an interface type from the system.collections namespace, which is used to support iteration. When enumerator is used for coroutines, it will cause the execution of your code to pause and resume at various points that you determine, iterating through them. So use enumerator and specify the name. Also, when you want to call the method, use a start coroutine, and in parentheses use the name of the method. You have to yield the return so you can wait for frames or seconds and then continue running the code. The major disadvantage of using coroutines is the way that they use memory. Memory is split into two locations for Csharp, the stack and the heap. Storing and accessing memory on the heap is more complicated than memory on the stack and can have significant impact on the efficiency of your game or application. Coroutines create temporary objects that are stored on the heap. As a very general rule, you should avoid this increased use of the heap unless you have a clear rationale for doing so. Also, the invoke function does the same, invoking the method by method name in the time second. Invoke is useful if you want to do something one time only. A coroutine is able to pause, let the game continue running, and then do something else later. Also, if you need to pass parameters to your method, consider using coroutine instead. Coroutines also provide better performance. Using namespaces in Unity comes with several benefits. It makes it easier to organize code, avoiding naming conflicts, and also improves code readability, testing, and readability. To easily add a root namespace, go to Edit, Project Settings, and Editor, and add a root namespace. Now when we create a new script, the namespace is automatically added. Project attributes are metadata markers that provide additional information or behavior to the fields, methods, and other elements within Unity scripts. For example, a tooltip will display a tip for the current object when your mouse hovers over it. You can use serialized field to display private variables in the inspector without making them public. Range allows you to declare a slider to limit a number to a specified range. A space adds a space between variables in the inspector, or you can use header to add a header. Require component automatically adds the require component, such as a RigidBody. It also prevents anyone from removing that required component, reducing the chances of errors when a script needs to communicate with a specific component type. You can find detailed information about each attribute in the Unity documentation. The instantiate function creates a copy of an object similar to the duplicate command in the editor. When cloning a game object, you can specify its position and rotation. Otherwise, they default to the original game object's position and rotation. If you're cloning a component, the game object it's attached to is also cloned. To use instantiate, you need to have a prefab of that object you want to copy. When you want to reuse a game object configured in a specific way, you need to create a prefab. This means dragging the game object to the project window and creating a prefab of that game object with all its components. You can then use that prefab in any scene or instantiate it. Remember, any changes made to the game object require overriding the prefab and updating. When you clone a game object or component, all child objects and components are also cloned, retaining their properties from the original object. This method allows you to create a bullet when you shoot, generate an effect during runtime, or perform various other tasks. The destroy function is used to remove a game object. You can also specify a delay before the object is destroyed by providing a time parameter. A render pipeline executes a series of operations that process the contents of a scene and display them on a screen. If you navigate to Edit, Project Settings, Quality, you will notice that the render pipeline assets field is empty. While you can create your own pipeline, this is a complex task. Unity offers 3 pre-built render pipelines with various capabilities and performance, or you can develop your own. The built-in render pipeline is Unity's default option, providing a general-purpose pipeline with limited customization options. The Universal Render Pipeline (URP) is a scriptable render pipeline that offers customization options and enables scalable graphics across various platforms. The High Definition Render Pipeline (HDRP) is another scriptable render pipeline designed for creating high-quality, photorealistic graphics on high-end platforms. Selecting the right Unity render pipeline is crucial during the early stages of development. Each pipeline offers distinct capabilities and performance, making them suitable for different types of projects and platforms. Switching between render pipelines can be time-consuming, especially for projects in advanced stages of development. Different pipelines use unique shaders and may lack certain features. URP is ideal for projects requiring rendering scalability across platforms, especially tile-based deferred rendering platforms and VR platforms. It's suitable for both 2D and 3D projects. HDRP is best suited for projects demanding photorealistic and high-fidelity rendering on high-end platforms, supporting only 3D projects. It targets the desktop, Xbox, and PlayStation platforms, utilizing advanced GPU hardware capabilities such as async compute shaders and ray tracing. To compare render pipelines and choose the right one for your project, refer to the link provided in the description. To download the Universal Render Pipeline or High Definition Render Pipeline, access the PackageManager, install the desired pipeline, and then create an assets pipeline and place it into the quality settings. The easier way is to start the project with URP or HDRP. Both of these pipelines have project samples. I highly recommend downloading them and giving them a try. Cameras are devices that capture and display the world to players. By customizing and manipulating cameras, you can make the presentation of your game truly unique. You can have an unlimited number of cameras in a scene. Also, in HDRP, only one camera at a moment can render. Unity displays different properties in the camera inspector, depending on the render pipeline that your project uses. Clear flags determine which parts of the screen will be cleared. This is handy when using multiple cameras to draw different game elements, so it can be set to a skybox or solid color. Background color is used when a solid color is chosen. The culling mask includes layers of objects to be rendered by the camera. You can assign layers to your objects in the inspector. Projection can be perspective or orthographic. Size, when orthographic is selected, determines the viewport size of the camera. Field of view is the camera's view angle, measured in degrees along the specified axis. You can set it to use a horizontal or vertical field of view axis. Most games use the horizontal angle. When the physical camera properties are enabled, Unity calculates the field of view using properties that simulate real-world cameras. You can check the settings yourself or refer to the Unity documentation. Clipping planes determine the distance from the camera to start and stop rendering. Depth is the camera's position in the draw order. Cameras with a larger value will be drawn on top of the cameras with a smaller value. Allow MSA enables multi-sample anti-aliasing for this camera. In URP and HDRP, there are settings to use anti-aliasing or dynamic resolution, among other features. Direct light is a light that is emitted, hits a surface once and is then reflected directly into a sensor, for example the eye or a camera. Indirect light is all other light that is ultimately reflected, including light that hits surface several times. To achieve realistic lighting results, you need to simulate both direct and indirect light. Real-time lighting is when Unity calculates lighting at runtime. Baked lighting is when Unity performs lighting calculation in advance and saves the result as lighting data, which is then applied at runtime. Lights are easy to use in Unity. You need to create a light of the desired type, for example from the menu, GameObject, light, point light. The type of the light is directional, point, spot, and area. The range is defined by how far the light emitted from the center of the object travels. Use the color picker to set the color of emitted light. Specify the light mode. Possible modes are real-time, mixed, and baked. And intensity set the brightness of the light. Shadow type determine whether this light casts hard shadows, soft shadows, or no shadows at all. You can also go to Window, Rendering, and Light Explorer to see all the lights in the scene. Global illumination is a group of techniques that model both direct and indirect lighting to provide realistic lighting results. Open the lighting window, menu, window, rendering, lighting. The baked global illumination system consists of light maps, light probes, and reflection probes. You can bake with progressive light mapper. By default, real-time lights contribute only direct lighting to the scene. If you enable real-time global illumination in your scene, real-time lights also contribute indirect lighting to a scene. Enlighten real-time global illumination is suitable for games targeting mid-level to high-end PC systems and consoles. Change settings for light mapping and bake your lighting to see what it looks like. Remember that only static objects can be used for baking. Also remember to check the Generate Light Mapping UV in 3D models. This will create a light map for the scene. I won't cover the settings, but Brackeys has a nice tutorial you can check out. In the environment section, you have options to add a skybox and control the intensity of the skybox and reflections of the skybox. A skybox is basically a big cube with different textures on each of its internal faces. These textures can be whatever you want. The problem with baked lighting is not all objects in your scene are static. Sometimes you want objects such as your player to move around, but still react to the different lighting conditions in your scene. Unity has a solution for this, it's called light probes. With light probes, you can get all the benefits of baked lighting on static objects while making sure that moving objects get better lighting. What we should do in light probes is to add certain points around our scene that will store the lighting information in that particular place. Import the audio file into Unity, and Unity will convert them as audio clip with some settings. Decompress on load. Audio files are decompressed as soon as they are loaded, suitable for smaller compressed sounds to avoid the performance overhead of decompressing on the fly. Not recommended for large files. Compressed in memory. Keeps audio compressed in memory and decompressed while playing, with slight performance overhead. Streaming decode continuous audio using a minimal amount of memory to buffer compressed data that are incrementally read from the disk and decode spontaneously. This option may affect CPU usage. Preload audio data. When enabled, the audio clip is preloaded after the scene is loaded, reflecting standard Unity behavior where all audio clips complete loading as soon as the scene starts playing. The specific format used for the sound at runtime depends on the currently selected build target. PCM offers higher quality at the expense of a large file size, suitable for short sound effects. Vorbis MP3 provides smaller files with somewhat lower quality compared to PCM audio, configurable via the quality slider, suitable for medium length sound effects and music. ADPCM useful for sounds containing noise and played in large quantities such as footsteps or impacts. Keep the sample rate as it is or use optimized. And the quality for Vorbis depends on the desired sound quality, with lower quality resulting in a smaller build size. To implement audio, create an audio source or attach an audio source component to a GameObject and assign the audio clip. Configure parameters such as the output audio mixer, which we will look at later in this video, mute, play on awake, which will start the sound as soon as the game starts, loop, priority, volume, pitch, panning, and 3D sound settings. In scripts, use the Unity engine.audio library and to get references from the audio source and play as needed. For example, calling the play function for a sound effect when pressing the F button, or trigger events like enemy hits or player deaths. You can also modify properties such as clip, time, loop, 3D settings, or stop the audio. A render texture is a type of texture that Unity creates and updates at runtime. To use a render texture, create a new render texture using Assets, Create, Render Texture, and assign it to the target texture in your camera component. Also, you can use the render texture in a material just like a regular texture. This is so useful for creating a minimap. I have a tutorial about it you can check out. In a demo I made to showcase the quality of HDRP, I used render texture for car cameras and it looked nice. A sprite represents an image for use in 2D gameplay. Set the texture type to a sprite and apply it. The sprite mode can be single or multiple. Use multiple when importing PSD files with different layers or images with separate parts. Pixels per unit determine the size of the sprite per unit. The mesh type tight use the exact border of an image. If your character is in the middle of the image and has empty space around it, tight mode will delete the empty space and keep the character. Full rect retains the empty space, which can be useful when creating an outline that requires the full image. Extrude edges determines how much empty area to leave around the sprite, and you can set the pivot accordingly. In the sprite editor, you can slice pieces of image. There are many other options available for sprite editing, such as creating bones. I won't cover other features of sprite editing, but I have a video about it on my channel you can check out. You can also enable read and write to modify changes to sprites in the script. Generate MIP maps is useful for textures, not sprites. MIP maps are commonly used for rendering objects in 3D scenes to reduce texture quality in the distance and increase GPU performance. However, they may not be beneficial in all cases as they increase the size of a texture by 33% both on disk and in memory. For pixel art, set the filter mode to point, no filter. You can also override settings for platforms and change the size and compression format. Compressing textures for Android and phones is essential for optimizing performance. Experiment with different compression formats to find the best balance between quality and performance. Use the sprite in the Sprite Renderer by creating a Sprite Renderer component and assigning the sprite to it. Unity's tilemap system stores and handles tile assets for creating 2D levels, which make it easy to create and iterate level design cycles within Unity. We have to show the type is sprite. We also change the pixel per unit to 16. The reason why is that the size of each tile in my tilemap is 16 by 16. And I want one tile to be 1 unit big. Then also, cause we are dealing with pixel art, we want to set the filter mode to point, so it doesn't get blurred out. And let's disable compression and apply the changes. We can open up the sprite editor, and here we want to define each individual tile. Likely we don't have to do all of this by hand. We can simply use the slice option here. And you can see actually automatically registers all of our tiles. We can simply click apply and close the window. Now we have each individual tile as the sprite. The next thing we need to do is create a tile map and choose whatever you want. So as you can see, it's created a grid, and because all tile maps in Unity are rendered using a grid. In each of these grid cells, we can now place tiles. We can change grid size or gap here. Expand the object, and here we have the tile map. Now we can consider a tile map in Unity kind of like a layer. If we want multiple tiles on top of each other, we simply want to create multiple tile maps that we can draw onto. It does have two components, a tile map which has the configuration for the layer, and tile map renderer where you can configure stuff like what material to use. Let's open up the tile palette by going to the window, 2D and tile palette. And this window is where we will find all our painting tools. Palette is basically just a collection of tiles. So let's create one and name it ground tiles. And it will be stored as an object in your project. We can select each sprite and drag it onto the tile palette. Unity will generate tile assets for each sprite. Now we can see them in the tile palette assets. We can simply brush it or delete it with the B or D shortcut. To create another layer, just go to Grid and right click and create another tile map. This way you can add tiles on top of the other tiles and also set the layer order to be greater than base ground. If you have these weird ugly lines in game view, we need to go to edit, project setting, and then quality, and here we make sure to disable anti-aliasing. And that's it. Just play with settings. It's simple, but if you need help, you can check out the Unity documentation. 3D models are created in external software, such as Blender, Maya, or other similar programs. A 3D model consists of vertices, edges, and faces. A 3D artist utilizes sculpting and polygonal modeling techniques to create complex models. These models can contain thousands of triangles and vertices. In the gaming industry, it is crucial to keep the triangles and vertex count as low as possible to optimize performance for the target platform. This helps avoid performance spikes in our game. While even low-end devices can handle millions of triangles at runtime without issues, it's generally better to optimize models for lighting, shaders, and other GPU or CPU processes that will run each frame. The preferred format for exporting 3D models to Unity is FBX. When importing a model, you have options to adjust its settings. If the model includes bones or rigs, you can specify the animation type as generic or humanoid, which we will discuss in the animation section. If animations are baked with the model in the 3D software, they will be displayed here. Also in the materials section, you can view the materials and export them to modify their properties. Textures are images that are used for many purposes, for example, for showing the surface of the 3D models. UV mapping is the 3D modeling process of projecting a 3D model's surface to a 2D image for texture mapping. The letters U and V denote the axes of the 2D texture for X and Y. This sphere is given a checkered texture in two ways, on the left without UV mapping and the right one with UV mapping. There are different types of textures for different purposes. The albedo map is the base texture and represents only the base colors of a surface. Normal maps give an additional surface angle information to the object, which affects lighting calculations. Height map, or known as parallax mapping, a map containing different heights per point on the surface of the model. It is a similar concept to the normal mapping, however this technique is more complex and therefore also more performance expensive. The occlusion map is used to provide information about which areas of the model should receive high or low indirect lighting. And other types of textures, for example cube maps, which features 6 faces and it's used for skybox or other things. I put a link in the description for information about all texture types. In Unity, you use materials and shaders together to define the appearance of your scene. To draw something in Unity, you must provide information that describes its shape and information that describes the appearance of its surface. You use mesh to describe the shapes and materials to describe the appearance of surfaces. Materials and shaders are closely linked. You always use materials with shaders. A material contains a reference to a shader object. Assign the material assets to the component's material property. For example, materials using the standard shader offer control over opacity or transparency, color adjustment, and the assignment of the textures we discussed earlier. Additionally, they allow for emission to enhance lighting and provide a glow effect to the material. Other settings include adjustment to the tiling and offset of the UV map, among others. You can create a video player from the hierarchy or attach a video player component to any game object. Source can be a video from your project or a URL. Update mode will set the clock source that the video player component uses to update its timing. DSP time use the same clock source that processes the audio. Game time use the same clock source as the game clock. This clock source is affected by the time scaling and capture frame rate settings. Unscaled game time use the same clock source as the game clock, but without being affected by time scaling or capture frame rate. Wait for the first frame of the source video to be ready for display before the game starts. You can set to playing when the game starts or loop the source video when it reaches its end. When you enable this option and the video player component detects drift between the playback position and the game clock, the video player skips ahead. You can change the speed of the video. You have to choose how the video will be rendered, render the video on render texture, or you could just show the video on camera. The following script demonstrates a few of the video player components features. The LOD Group component manages level of detail LOD for game objects. The level of detail LOD technique is an optimization that reduces the number of triangles that Unity has to render for a game object when its distance from the camera increases. You can set renderers, for example 3 LOD for a mesh, which you should create on 3D external software, and then you can control the transitioning between LOD levels. Fade mode can be crossfade, which will fade slowly, or speed tree for users that use speed tree software, or you can create the fade mode in shaders. I have a video about it if you want to check it out. Also, there is a LOD bias in project settings, quality, that will set the global multiplier for the LOD's switching distance. A larger value leads to a longer view distance before a lower resolution LOD is picked. Use the LOD technique for optimizing the 3D games for a range of devices. As I said before, we should optimize our mesh and our triangles count for 3D mesh in external software, and LOD is another option that can boost the performance and avoid the spike in our performance. The Unity editor includes a built-in set of trains features that allow you to add landscapes to your game. In the editor, you can create multiple train tiles, adjust the height or appearance of your landscape, and add trees or grass to it. At runtime, Unity optimizes built-in train rendering for efficiency. Before proceeding, I recommend downloading the Train Sample Assets pack from the Unity Assets store. It contains textures and 3D models that will prove useful for our purposes. To add a train game object to your scene, select Game Object, 3D Object, Train from the menu. The toolbar provides 5 options to adjust your train. Create adjacent train tiles, sculpt and paint your train, add trees, add details such as grass, flowers and rocks, change general settings for the selected terrain. The Create Neighbor Train tools allows you to quickly create adjacent train tiles which automatically connect. In the Train Inspector, click the Create Neighbor Trains icon. When you select the tool, Unity highlights areas around the selected train tile, indicating spaces where you can place a new connected tile. Before proceeding further, let's explore the train settings. You can check this box to enable rendering of the train. Pixel error, the accuracy of the mapping between train maps such as height maps and textures, and generated train. Higher values indicate lower accuracy but with lower rendering overhead. Base map, the maximum distance at which Unity displays train textures at full resolution. Beyond this distance, the system uses a lower resolution composite image for efficiency. Other things is for lighting and materials. In the tree and detail object section, you set the detail distance or tree distance. In the mesh resolution section, you can change the width, length, and height of the train. Detail resolution, the number of cells available for placing details onto the train tile. Click on Paint Train. You can select what you want to do with train. You can raise or lower the train or paint textures and other things. In Paint Texture, you can add layers and do painting. Additionally, the Train Tools package available in the PackageManager offers more advanced features useful for creating complex looking train. When painting trees, the collider is always a capsule collider. Tree colliders will bake with train colliders, preventing access to the trees in scripting. Making changes to the train collider at runtime is expensive. So if you plan to create a game with falling trees or chopping trees, I don't recommend using paint trees on train. Paint details is used for bushes, grasses, and other elements. However, remember that details cannot have LOD, and they cannot have colliders. There are 2 excellent Unity assets available for free that you can download to see how they create their trains and assets. Unity provides a tool called Tree Editor that lets you design trees directly within the editor. This is very useful when you want to create detailed forests and jungles with different tree types and variations. Also, there is another external tool called SpeedTree for advanced users, but you have to pay for it. To create a new tree asset, select GameObject, 3D Object, Tree. You will see a new tree asset is created in your project view and instantiated in the currently open scene. This new tree is very basic with only a single branch, so let's add some character to it. Select the tree to view the tree window in the inspector. This interface provides all the tools for shaping and sculpting your trees. You will see the tree hierarchy window with 2 nodes present, the tree root node and a single branch group node, which we will call the trunk of the tree. Click on the Add Branch Group button and you will see a new branch group appear connected to the main branch. Now you can play with the settings in the branch group properties. We decorate our tree with leaves by adding leaf groups, which basically work the same as the branch groups we have already used. In order to make our tree realistic looking, we need to apply materials for the branches and the leaves. Create a new material in your project using assets create material. Rename it to My Tree Bark and choose a nature tree creator bark from the shader dropdown. From here you can assign the texture provided in the tree creator package to the base, normal map and gloss properties of the bark material. You can find more information about the tree editor in the Unity documentation. To create the effect of wind on your train and particle systems, you can add 1 or more GameObject with a WindZoon component. Trees within a wind zone bend in a realistic animated fashion, and the wind itself moves in pulses to create natural patterns of movement among the trees. To create a WindZoon GameObject directly, go to Unity's top menu and then go to GameObject, 3D Object, WindZoon. You can add the WindZoon component to any suitable GameObject already in the scene. You can set the mode to directional or spherical. Spherical is useful for creating special effects like explosions. The main property determines the overall strength of the wind, and you can use turbulence to give these some random variations. The wind blows over the trees in pulses to create a more natural effect. You can control the strength of the pulses with pulse magnitude and the time interval between them with the pulse frequency. The Trail Renderer component renders a trail of polygons behind a moving game object over time. This can be used to give an emphasized feeling of motion to a moving object or to highlight the path or position of moving objects. To create a trail renderer, in the Unity menu bar, go to GameObject, FX, Trail. Select a Trail Renderer GameObject and parent it to the GameObject that you wanted to generate a trail for. You can change the width or look of the trail. The line renderer component takes an array of 2 or more points in 3D space and draws a straight line between each one. You can use a line renderer to draw anything from a simple straight line to a complex spiral. In the Unity menu bar, go to GameObject, FX, Line. Select the line renderer GameObject. Add points to the line renderer's position array either by directly setting array values in the inspector window or in the script. I have a video about draw line renderers with physics. You can check it out to see how to implement it in your project. The line is always continuous. If you need to draw 2 or more completely separate lines, you should use multiple game objects, each with its own line renderer. A particle system simulates and renders many small images or meshes, called particles, to produce a visual effect. Each particle in a system represents an individual graphical element in the effect. The system simulates every particle collectively to create the impression of the complete effect. There are 2 particle system solutions. The built-in particle system, a solution that gives you full read and write access to the system and the particle it contains from a Csharp script. You can use the particle system API to create custom behaviors for your particle system. The visual effect graph, a solution that can run on the GPU to simulate millions of particles and create large-scale visual effects. This board shows the difference between built-in particle systems and visual effect graph. Which one should you use? Of course, this is not the right question to ask, cause some effects should be done in particle effect and some on visual effect graph. Also, for mobile devices that do not support compute shaders, you can't use visual effect graph. Visual effect graph is faster cause it's done in GPU and the quality and instances are much higher than the particle effect. But this doesn't mean you don't need built-in particle system. So, we will see the visual effect graph in another part of the video. Now let's see the built-in particle system. Placing a particle system in a scene is a matter of adding a pre-made GameObject, GameObject FX particle system, or adding the component to an existing GameObject, component FX particle system. Because the component is quite complicated, the inspector is divided into a number of collapsible subsections, or modules that each contain a group of related properties. The first 3 modules and the last module are almost used. There are particle system, emission, shape, and render modules, which are all enabled by default. The rest of the modules contain more specific settings for different use cases. So let's see the first one. The particle effect module has the most important settings. This module contains global properties that affect the entire system. You can control whether the system should loop, the duration of the system, and if you want to have it play automatically. These are the start settings for your particle, which includes lifetime, speed, size, rotation, and color. Also, you can use modifiers to make each property random. You can also add gravity and simulation space. Here we decide if we want to follow around your object or move independently. The emission module handles the creation of particles, rate over time, rate over distance, and burst. The first one is simply affects how much time passes between each particle emission. The second one is used to define how far the object needs to move before another particle is emitted, especially useful for moving vehicles emitting smoke. Finally, you can set up bursts to where you fire off bunch of particles at once. In the shape module, we choose the shape of the emitter. There are many shapes that you can choose from, such as a sphere, hemisphere, cone, donut, and others. The rest of the properties for this module will control how the particles are emitted. The render module is extremely important. This is where you define the look of your particles using the render mode. We can choose if we want to show the particles on the 2D surface, which we call billboard, or as a 3D mesh. Other modules like over lifetime modules, like this one in here, we use these to change properties on the particles over time after they get emitted. There are tons of other things about particle effect, but that's enough for now. There is a legacy particle pack asset free from Unity that you can download and learn from. Also, Gabriel does have great videos about particle effects, you can check them out. There are two types of input systems in Unity, the legacy input system and the new input system. The new input system is very flexible and it's better to use for production. For this section, let's look at the old input system, which we will be used for prototyping and testing. The old input system is straightforward to use. For example, in an update loop, we can use input.getKey or getKeyDown, which triggers immediately when the button is pressed, or getKeyUp when the button is released. You can specify the key code of the button you want to monitor within parentheses. You can utilize getMouse button with 0 representing the left click mouse button and 1 for the right click button. You can get information about the vertical and horizontal axes using the getAxis function. In parentheses, you should use the exact string names set up by Unity. These axis names can be found in the project settings under Input Manager. For instance, fire corresponds to the left click button, jump, and the mouse axis. You can store the vertical and horizontal axis values and use them to move objects. For example, the following code is used to move an object. The translate method moves the transform in the direction and distance of the vector provided to it. Time.deltaTime ensures a smooth movement regardless of frame rate. There are multiple ways to move an object, including using physics with RigidBody or directly manipulating the transform. I have included a link in the description that explains various types of movement for characters or cameras in Unity. The character controller component is mainly used for third-person or first-person player controller that does not make use of RigidBody physics. Slope limits the collider to only climb less steep slopes in degrees than the indicated value. Step offset the character will step up a stair only if it is closer to the ground than the indicated value. Skin width to colliders can penetrate each other as deep as their skin width. A larger skin width reduces jitter, a low skin width can cause the characters to get stuck. A good setting is to make sure this value 10% of the radius. Mean move distance: if the character tries to move below the indicated value, it will not move at all. This can be used to reduce jitter. In most situations, this value should be left at 0. Radius length of the capsule collider's radius, this is essentially the width of the collider. Hide the character's capsule collider height. Changing this will scale the collider along the y-axis in both positive and negative directions. A character controller is not affected by forces and will only move when you call the move function. It will then carry out the movement but be constrained by collisions. Here we have created a simple script that retrieves input axes and utilizes them in characterController.move to move the character. Additionally, we check if the character is on the ground and the jump button, defined as a space, is pressed. When this happens, it stores the calculation in a vector3 variable we have created called player velocity, and again we use the character controller to move the object upwards. There are some samples you can download and see how it's implemented. The Skinnet Mesh Renderer component is like Mesh Renderer, but it renders a deformable mesh. Deformable mesh include skinnet meshes, meshes that have bones and bind poses, meshes that have blend shapes, and meshes that run clove simulations. Bones are the basic 3D model's skeleton, which defines how the model can move and deform. Bounds set the bounding volume that Unity uses to determine when the mesh is off-screen. Unity calculates the bounds when importing the mesh and animations in the model file, and display the bounds as a wireframe around the model in the scene view. If your 3D model do have blend shapes, it will show it here. And the blend shape is a way of deforming geometry to create a specific look for your mesh. Quality sets a runtime cap for the maximum number of bones that can affect the vertex. A higher number of influential bones might affect performance. Auto means it will use the global limit set in quality settings, skin weights. Root bone set the transform that is the root of the skeleton. The bounds move along with this transform. When you drag a 3D model with a bone to the scene, it will automatically create a Skinnet Mesh Renderer and a root bone. Decals are materials that decorate the surface of other materials. They are most commonly used for effects like paint splatters and stickers. For URP, you have to add the Decal Renderer feature to the URP renderer. Go to Rendering and URP Decal Projector, or add the component to an empty game object. We need to create a new material, and for the shader reference, use the shader graph decal. We will talk about the shader graph, but if you want to, you can edit and create your own shaders for decals. Give it a texture. If you have normal map for that texture, assign it here. You can use scale, crop, or pivot tools to make changes. You have option to change the tiling and offset, and also opacity and draw distance to make changes. In an HDRP project, it's a little easier. You just go to Hierarchy and Rendering and choose the HDRP Decal Projector. It's exactly like the URP. Create a material and set the shader HDRP Decal. Change the settings to see what each one does. Unfortunately, built-in project doesn't support decals, but there is a replacement for it, which is the projector component. Lens flares and halos are lighting effects that can add atmosphere to your scene. First, create a flare asset and assign your custom flare texture. If you don't have one, just go with the default particle. Set the texture layout to one texture, and elements are basically the amount of flare we want. I only use one element, which is going to be near the sun. The position is going to be 0. Let's increase the size. You can see we are not able to preview it. The reason is we need to assign the flare assets to the directional light in the flare section. You can change the color if you want, and also you can use the light color and the rotation of the sun or other things. In the built-in renderer pipeline, if you want a camera to see lens flares, you must attach a flare layer component to the camera's GameObject. If you assign it to the flare property of a light component, Unity automatically tracks the position and direction of the light and uses those values to configure the appearance of the lens flare. Lens flares are a little difference in URP and HDRP. Halos are glowing areas around light sources. Use them to give the impression of small dust particles in the air and add atmosphere to your scene. So I have a point light here. Add the halo component to a game object with a light component. A light can also display a halo without a separate halo component by enabling its draw halo property, but you cannot change its size and color. A singleton in Unity is a globally accessible class that exists in the scene but only once. The idea is that any other script can access the singleton, allowing you to easily connect objects to important parts of the game, such as the player or other game systems, like an audio manager, game manager, or scene manager scripts, if there is only one in a scene. To make your class a singleton, create a static instance of your class. The static reference is what makes it singleton globally accessible. It's important to ensure that there is only ever one instance of the singleton by checking. So in the awake function, we check if there are other instances the same as this one. If there are, we destroy this one. Otherwise, the property we have created will be used to assign this class to it. Now in any other class like player or enemy, we can just use the class name and the static property we created, and then we have access to the class without needing a reference to it. Another example is if we have an audio manager that runs a function to play a sound. Because the audio manager script is going to be used only once, we will make it a singleton and then easily use it whenever we want to call a function. There is more about singletons. I will put a link in the description to explain singleton in detail. A scriptable object is a data container that you can use to save large amounts of data, independent of class instances. One of the main use cases for scriptable objects is to reduce your project's memory usage by avoiding copies of values. Every time you instantiate that prefab, it will get its own copy of that data. Instead of using this method and storing duplicated data, you can use a scriptable object to store the data and then access it by reference from all of the prefabs. This means that there is one copy of the data in memory. You cannot attach a scriptable object to a game object. Instead, you need to save them as assets in your project. To create a scriptable object, right-click in your project window and select Create Csharp script. I name it Player Data. By default, new scripts inherit from monobehavior, which is what allows them to be added to game objects as components. To create a scriptable object class instead, replace monobehavior with a scriptable object. Just like any other script, you can declare variables in the body of the class. For instance, in this basic example, I might add a health value, a magic value, and a vector tree position to track where the player is. To use a scriptable object, you will need to create at least one instance of it. And generally, the easiest way to do this is by adding the Create Access menu attribute to the scriptable object class. This attribute will allow you to create scriptable object instances from the Create menu by right-clicking in your project window, which will then create a new instance. Each asset is unique, just like a script component on a game object, meaning that you could create just one player data asset, as I have done here, or multiple player data files where each one provides live data about a particular player, but using the same data type. Selecting the assets in the project will display its specific values in the inspector, just like when selecting any other assets. Now, for example, a player class that's attached to an object might hold a reference to a player data asset, which it can use to update the player's position as the game runs. Then to connect the player object in the scene with a specific player data asset in the project, simply drag it to the field or use the circle select button. The main purpose of a scriptable object is to store instances of data outside of the scene. This is useful when data itself doesn't belong to any one scene, such as settings data, profiles, and item configurations, as it allows you to create the data in the inspector and access it from anywhere in your game, just like any other asset. However, it's also possible to specify the name of the menu item that will appear. There are a couple of differences between a monobehavior script that's attached to an object and a scriptable object class that exists in your project. For example, regular script components are temporary. They exist in the scene, and unless the object they are attached to is preversed using don't destroy unload, the script and its data will be lost when the scene changes. Scriptable objects, on the other hand, because they are assets, exist outside of the scene, meaning that their data will remain the same when the scene changes or in the editor, even when editing play mode. which can be useful for passing data between scenes. I will put a link in the description for more details about scriptable objects. Let's take a look at the basics of UI or user interface. UI is most commonly used to create game menus, make buttons two players can interact with, or some text to display the game's rules or display credits. It's also an extremely important part of actual gameplay. For example, the health bar is UI, and the inventory, the dialog boxes, all of this is UI. We should make sure that the UI looks good on multiple screen resolution. First, create a canvas. You can see an event system pop up in the hierarchy. Take a look at the canvas scaler components attached to it and change the UI scale mode to scale with screen size. For width and height, type out the same values as your current game resolution, visible at the top of the game window. So I type 1920 width and 1080 height. This is important as we will make sure that our UI scales properly and reduces or increases the size of my screen. For creating a UI element, go to Hierarchy and UI. Here you can see different elements. Let's choose TextMesh Pro. TextMesh Pro is a separate package that only needs to be imported to your project, so do it. Let's increase the size. At some point the text may get cut out. Simply we need to increase the size of the text elements in our scene. I will change the text displays right here, for example coins. Let's say I wanted these coins display in the top left corner of my screen. You could simply move it with the translate tool, but the UI won't look right if you then change the resolution. So instead you need to use the anchor preset. You will need to hold down both the Shift and Alt and then click on one of these 9 squares. Each one of will snap your text to a certain part of the screen. Now changing the screen size won't change the fact that it is still in the top left corner of the screen. Now you have done that, you can tweak its position and things still work fine. If you want to change the text in the script, for example showing how many coins does player has, create a script and for example drag and drop it on the text. Make sure to add using the Unity engine.ui and TM Pro namespace right up here. I create an int and set the amount equal to 10 and the public variable of TextMesh Pro UGI called coins text. In my update function I will get this coins text displaying the word coins and plus my coins value. And for example if I hit the right click, the coins will increase by 1. Heading back to Unity, now we need to drag and drop the TextMesh Pro component, and as you can see it displays the text as we set, and now I can hit the right click of my mouse and increase the coins by 1. You can also change the color of the text, or if you have imported the font, go and create font assets and then use it here. There are other settings like auto size or alignment. If wrapping is disabled, all the text will remain as you write, and if you change the size it won't change. There are other settings like outline or color gradients and font style, which is simple. Just play with the settings and you will see what each of them do. You can also add images to the scene. If you have a sprite in your project folder, you can drag and drop it in the sprite section of the image component. You can set the native size and then resize it. Another feature is the button. You will use this for your game's main menu, pause menu and more. Just go to UI and create a new button with Text Mesh Pro. If you don't want the text, just delete it. Button does have an image component, so you can change the sprite to whatever you want. The main purpose of buttons is to call a function in your script when clicked on. So I create a GameManager script and attach it to an empty GameObject. Inside it, I create a public function called add coins, and every time it calls, it will add the coins and then I will update the text. Make sure your function is public or you won't be able to call it from your button. In button, add on click an event and now needs to drag and drop my game manager inside this empty slot. And now I can search for the function I wish to call. So find the script and then the name of the function, which mine is add coins. When I click on the button, you can see that my coins will increase and that means our function is working. You can also change the look of the button when it is pressed or hover with the mouse. Also, you can change the transition to sprite or animation to change the sprite when you click or hover. If you disable the interactable, then your button won't work. You can disable this with the script to avoid the player using the button. UI is a huge topic, so that's enough for now. You can check other elements and search for what each of them can do in Unity tutorials. UI Toolkit is another UI system for your game. It's new and UI Toolkit is inspired by standard web technologies. If you have experience developing web pages or applications, your knowledge is transferable and the core concepts are familiar. Unity recommends you to use the UI Toolkit for your new UI development project. However, Unity UI, UGI, and IMGUI are appropriate for certain use cases and are required to support deprecated projects. For creating animations, you need two tabs, Animation and Animators tabs. Animation and Animators are really important for any game. It's a huge topic, so I can't cover all of the details and we will just look at how it works. Open Animation through Windows, Animation, Animation. The Animation tab is where you can animate your objects. To create animation clip, first you have to select the game object that you want to create animation clip for, then hit the create button. This will create an animator controller and the animation clip. You can also create an animator controller or animation through the project. If you select the object, you can see that it does have an animator component with a cube animator controller. If you open the animator controller tab, it will show all the animation clips imported for that animator. For now, we have created one animation clip. Click on the animation tab and select a cube or any object you have. Here it will show you the animation you are editing. You can also create a new clips. There are records, play or go to next or previous frame of animations button. If you click record, you can make changes to the selected object, which should be the object that has this animator, and then set what you want to do for each frame. For example, if you want to make the cube scale to 3 in the first second of your animation, then wait for 2 seconds and then start making it small. This is where you can make your animation clips. Also, animation clips can be imported from external software. When you import 3D models in the rig section, you can set the animation type to generic or humanoid. Humanoid is a type of bone created for humans. Then create an avatar and set each bone if it is not set up already. Humanoid is very useful because the animations can be used for all the 3D humanoid models. So if you have a walk animation for humans, you can easily use it for all of your 3D humanoid type models. Generic is used for other purposes. For example, if you have an animal or a strange shaped character. Remember that a humanoid animation can't be edited and can't be created in Unity. You can use assets like UMotion to create, but Unity doesn't support that for now. You can find great animations in Mixamo. Also, if you import models with animation, you can see the animations in the animation section, and you have some option to change animations settings. Animator controller is a controller that has a reference to the animation clips used within it and manages the various animation states and the transition between them. The animator window has two main sections, the main gridded layout area and the left-hand layers and parameters panel. The main section with the dark gray grid is the layout area. You can use this area to create, arrange and connect states in your animator controller. You can right click on the grid to create a new state node, use the middle mouse button or alt to pan the view around, click to select a state node to edit them, and click and drag a state nodes to rearrange the layout of your state machine. The left-hand panel can be switched between the parameters view and the layers view. The parameters view allows you to create view and edit the animator controller parameters. These are variables you define that act as inputs into the state machine. To add a parameter, click the plus icon and select the parameter type from the pop-up menu. The basic idea is that a character is engaged in some particular kind of action at any given time. The actions available will depend on the type of gameplay, but typically actions include things like idling, walking, running, jumping, and others. In general, the character will have restrictions on the next state it can go to rather than being able to switch immediately from any state to any other. For example, a running jump can only be taken when the character is already running and not when it is at a standstill. So it should never switch straight from the idle state to the running jump state. The options for the next state that a character can enter from its current state are referred to as state transition. So for example, use transition to connect idle to walk animation and also do it reverse. Then use a boolean and name it walking. Then in the transition of idle to walk, say if walking is true, go to walk animation. And in the walk to idle, say if walking is false. Then in the script, you can catch the animator controller and use the set booleans with a name which should be exactly the same as we write in the parameter panel and set the value. As you can see, if I press W character, will start walking and it transition to walking animation. And if I stop, it will go to idle animation. So we just had an overview for the animation and animator section. There is a lot to cover and it's not in the scope of this video. Unity can build your application for different platforms and with different settings. Go to File, Build Settings. When you build your application, Unity builds all selected scenes in the Scene in Build panel. So put the scene that you want to be in your application here. You can add, exclude, remove, and reorder scenes in the list. Each build must have a target platform. The platform panel lists all the platforms you can build for. You need to download the module for each build from Unity Hub and then switch to that target platform. This switch process can take a long time. Unity produces two build types. A release build, which includes only what's necessary to run the application. This is the default build type. And the development build, which includes scripting, debug symbols, and the profiler. Click on Player Settings. This will open up the settings required for your build. The player settings differ between the platform modules that you have installed. Each platform has its own player settings, which you will need to set for each version of your application you want to build. Enter the name of your company. Unity uses this to locate the preferences file. Enter the name of your game and set the version. You can set up a default icon and cursor for your game. Icon section is the game icons as shown on the desktop. You can choose icons from 2D image assets in the project, such as sprites or imported images. Resolution and presentation. Settings for screen resolution and other presentation details, such as whether the game should default to full screen mode. This section allows you to specify how the user can customize the screen. For example, you can determine whether the user can resize the screen and how many instances can run. Splash image, the image shown while the game is launching. This section also includes common settings for creating a splash screen. Also, you can disable the Unity splash screen in Unity 6. Other settings is the most important part. Choose which color space to use for rendering, gamma or linear. Enable this option to use the best graphics API on the Windows machine the game is running on. Disable it to add and remove supported graphics API. Enable these two options to use static batching and dynamic batching. Compute skinning, enable this option to enable DirectX 11 and DirectX 12 compute skinning, freeing up CPU resources. Enable graphics jobs to work in threads running on other CPU cores. This is intended to reduce the time spent on camera.renderer on the main thread, which is often a bottleneck. The scripting backend determines how Unity compiles and executes Csharp code in your project. Mono compiles C# code into .NET Common Intermediate Language (CIL) and executes that CIL using a Common Language Runtime. IL2CPP compiles C# code into CIL, converts the CIL to C++, and then compiles that C++ into native machine code, which executes directly at runtime. It's recommended to use IL2CPP for your last build. It takes longer to build your app, but it does have better security and performance. Choose which .NET APIs you can use in your project. Try to leave other settings as it is and change them when you have a complete understanding what are you going to do. Now it's ready to click on build and wait for minutes to finish. Shaders are tiny programs that run on your GPU, graphics processing unit, and change the way objects look in your scene. They are written in programming languages like GLSL, OpenGL Shading Language, or HLSL, DirectX High-Level Shading Language, that are specifically made for writing shaders. This lets you control how the GPU processes and renders graphics. With shaders, you can change object colors, reflections, lighting, and other visual properties to create a wide variety of effects and styles for your game. For example, you can use a shader to make characters look hand-drawn, grass look soft or fuzzy, or metal objects look shiny or reflective. But shaders aren't just for changing the way objects look. You can also use them to create special effects like surface deformations. For example, you can use a vertex shader to dynamically change an object's shape to simulate ocean waves or stretch and squash effects. These effects can add realism to your scene. There are various types of shaders, including pixel shaders, vertex shaders, and geometry shaders, each capable of making different kinds of changes to your graphics. 2D shaders only work on images, also known as textures. They modify pixel attributes and can be used in 3D graphics. Pixel shaders, the only type of 2D shader, manipulate the color and other attributes of each fragment, a unit of rendering affecting 1 pixel. Pixel shaders can create simple or complex effects such as always outputting the same color or adding lighting. 3D shaders operate on 3D models or other geometry and can also access the colors and textures used to draw the model. Vertex shaders, the most common type of 3D shaders, run once for each vertex. They transform the 3D position of each vertex to the 2D position on the screen and add a depth value for the Z buffer. Vertex shaders can change properties like position, color, and texture coordinates, but they can't create new vertices. Geometry shaders can generate new vertices and primitives, such as points, lines, and triangles, from input primitives. Tessellation shaders add detail to batches of vertices at once, such as subdividing a model into smaller groups of triangles to improve curves and bumps. Compute shaders are a type of shader that allows developers to perform general-purpose computing tasks on the GPU. They are used to perform tasks that are not related to rendering graphics, such as image processing, simulation, and artificial intelligence. On the other hand, ray tracing shaders are a type of shader that is used to simulate the physical behavior of light in real time. They are used to create realistic lighting and shadows, reflections, and refractions in the scene. They work by tracing the path of light rays as they bounce off of objects in the scene and calculating how they should be rendered. Shader Graph is a tool that enables you to build shaders visually instead of writing code. You create and connect nodes in a graph framework. Shader Graph gives instant feedback that reflects your changes, and it's simple enough for users who are new to shader creation. For learning shaders and shader graph, I highly recommend downloading samples by going to PackageManager, shader graph, and in samples there are node reference that you can import, which will explain all nodes with details, and there are many examples that you can get by importing feature examples. VFX Graph is similar to particle system, but it works on GPU. It gives you the best performance. VFX Graph uses a mix of flow and node-based authoring. Flow authoring assembles building blocks for spawning, initialization, update, and rendering stages on which a combination of nodes can be plugged to create advanced procedural effects. If you have worked with a shader graph, VFX Graph will be similar to you. VFX Graph works with the Universal Render Pipeline, URP, URP's 2D render, and the High Definition Render Pipeline. HDRP. For more advanced effects, you can visually author your own pixel and fragment shaders with Shader Graph and use them in VFX Graph. This approach allows you to create custom looks, use advanced lighting models like HDRP's hair and fabric shaders, as well as animate vertices to deform or animate particles on the GPU for effects like bubbles or flocks of birds. There is a great ebook that explains the VFX Graph in detail. Also, Unity YouTube does have some great tutorials for VFX. High dynamic range HDR is a technique that produces images with a greater dynamic range. The difference between the darkest and brightest information a game can display. For built-in, enable HDR rendering per camera in the inspector or using the camera.allow HDR API. In URP, enable HDR rendering for all cameras using the universal render pipeline assist. And in HDRP, HDR rendering is enabled for all cameras by default. You cannot disable it. Unity provides a number of post-processing effects and full-screen effects that can greatly improve the appearance of your application with little setup time. You can use these effects to simulate physical camera and film properties, or to create stylized visuals. The images below demonstrate a scene with and without post-processing. The built-in render pipeline does not include a post-processing solution by default. To use post-processing effects with the built-in render pipeline, download the post-processing package. URP and HDRP include its own post-processing solution, which Unity installs when you create a project using URP or HDRP template. The anti-aliasing effect softens the appearance of edges in your scene. The exposure effect dynamically adjusts the exposure or brightness of the image. The bloom effect makes bright areas in your image glow. The channel mixer lets you adjust the balance of each input color. The chromatic aberration effect disperses colors along the boundaries between dark and light areas of the image. The color adjustments effect lets you change the overall tone, brightness, and contrast of the final rendered image. The fog effect simulates the look of fog or mist in outdoor environments. The depth of field effects blurs the background of your image while the objects in the foreground stay in focus. The grain effect overlays film noise onto your image. The lens distortion effect simulates distortion caused by the shape of a real-world camera lens. The lift gamma gain effect allows you to perform three-way color grading. The motion blur effect blurs the image in the direction of the camera's movement. The Pinini projection effect corrects the distortion at the edge of an image caused by a wide field of view. The shadows midtones highlights effect separately controls the tint and brightness of the shadows, midtones and highlights in your game. The split toning effect maps two different tones in your image to two specific colors. The tone mapping effect remaps the values of an image to high dynamic range HDR colors. The vignette effect darkens the edges of an image. The white balance effect preserves the white areas in your image and balances other tones around the white areas. A sky is a type of background that a camera draws before it renders a frame. This type of background greatly benefits 3D games and applications because it provides a sense of depth and makes the environment seem much larger than it actually is. A sky itself can contain anything such as clouds, mountains, buildings, and other unreachable objects. Unity can also use a sky to generate realistic ambient lighting in your scene. The built-in render pipeline and URP use a skybox material to define a sky for cameras to draw. Go to lighting window and set up the skybox and settings. HDRP includes its own sky solution that uses the volume system. Each volume can include an override to specify a type of sky to draw. In your volume, add the visual environment. HDRI skies uses a cube map texture to represent the entire sky. Physically based sky simulates the sky of a spherical planet. Or use a gradient sky, which is the simplest one here. Background clouds renders clouds using the cloud layer system. Ambient mode can be static and dynamic. The built-in and URP go to lighting window and environment, and there is an option to turn on fogs in your scene. In HDRP, you have to add global fog from your volume component. Change each setting to see what each one does. You may want to have fog effects in your scene that a global fog cannot produce by itself. In this case, you can use local fog. To add localized fog, use a local volumetric fog component. Also remember that you have to turn on the volumetric fog in your HDRP assets and turn on local fog in global fog to work. There are good examples in HDRP packages that you can import and see what they look like. The Volumetric Clouds is only supported in HDRP. Volumetric Clouds are interactable clouds that can render shadows and receive fog and volumetric light. To set up Volumetric Clouds, you need to go to your HDRP assets, lighting, and enable the Volumetric Clouds. In the volume component, navigate to Add Override, Sky, and click on Volumetric Clouds. Unity is more than an engine. It also brings a growing range of integrated services to engage, retain, and monetize audiences. To start using Unity services, you must first link your Unity project to a project ID. Open the Services window, General, Services. Select your organization from the drop-down. Use an existing Unity project ID to link a project to an ID you previously created on the developer dashboard, or create a project ID to link your project to a new ID. If you open up your dashboard and in products, it will show you all the Unity services. There are Unity Clouds analysis, in-app purchases, leaderboards, multiplayer services, and version controller. Source code management, also referred to a version controller, is how team tracks and manage their projects, code and backup projects. You can think of a source code management tool as the source for the programmers, artists, and other team members who are contributing to your project's code base. You can also use GitHub Desktop, create your repository, and in GitHub Desktop locate the folder and then just commit and push it to your GitHub. This way you can always get a backup for your project. Open quality settings from project settings. Unity allows you to set the level of graphical quality it attempts to render. Generally speaking, quality comes at the expense of frame rate, and so it may be best not to aim for the highest quality on mobile devices or older hardware, since it tends to have a detrimental effect on gameplay. Unity lets you assign a name to a given combination of quality options for easy reference. The rows of the matrix lets you choose which of the different platforms each quality level applies to. The default row at the bottom of the matrix is not a quality level in itself, but rather sets the default quality level used for each platform. A green checkbox in a column denotes the level currently chosen for that platform. You can set the render pipeline access to use for this quality level. Set the maximum number of pixel lights when Unity uses forward rendering. Choose the level of multi-sample, anti-aliasing, or enable this option to update reflection probes during gameplay. Then scales the device's screen resolution below its native resolution. VSync is an important part. Choose to synchronize rendering with vertical blanks or not to synchronize at all. Unity can synchronize rendering with the refresh rate of the display device to avoid tearing artifacts. The available options are every V-blank, every second V-blank, or don't sync. Real-time GI CPU usage. The CPU budget you allow Enlighten real-time global animation to use for lighting calculation at runtime. Increasing this makes the system react faster to changes in lighting at the cost of using more CPU time. There are other things like set texture quality, the maximum amount of raycast, terrain settings or shadows, or maximum LOD levels. The input system allows you to control your game or app using a device, touch, or gestures. Unity supports input through two separate systems, one older and one newer. The older system, which is built into the editor, is called the Input Manager. The Input Manager is part of the core Unity platform and is the default. This input system package is a newer, more flexible system which allows you to use any kind of input device to control your Unity content. It's intended to be a replacement for Unity's classic input manager. It is referred to as the input system package or just the input system. To use it, you must install it into your project using the package manager. Also go to project settings and player. In other settings, enable both input systems. The input system stores your input configuration in an action assist. When you first install the input system package, you must create this action assist. You can do this by creating an action assist in project window and create and then action assist. Action maps displays the list of currently defined action maps. Action map is a collection of actions that you can enable or disable. For example, we can have a player map and UI map. Actions displays all the actions defined in the currently selected action map and the bindings associated with each action. So for example, I will create an action and name it move. And I set the action type to value and control type to vector2. You can also add interactions or processors. After that, add up, left, right, down composite and then set the bindings. Then let's add another action and call it jump with action type button. Then add bindings. This setup was for the keyboard, but now we can easily extend this to gamepad or touch. And also you can add a control scheme. When you finish, click the Save Assist button. There are different ways to use this input action assist. Let's look at the easiest one. In our script, we can use input system library and then get a reference for the input action assist. And then save the actions we have created in a variable. Then in the start, catch the actions. And in the update, use the read value to get the vector2 value and use it in your movement logic. For jump, just check if it is pressed or not. Input system have a lot of features and setup. You can search on the internet and find complete tutorials for it. The Unity Profiler is a tool you can use to get performance information about your application. You can connect it to devices on your network or devices connected to your machine to test how your application runs on your intended release platform. The profiler gathers and displays data on the performance of your application in areas such as the CPU, memory, renderer, and audio. It's a useful tool to identify areas for performance improvement in your application and iterate on those areas. You can pinpoint things like how your code Assets, scene settings, camera rendering, and build settings affect your application's performance. It displays the result in series of charts so you can visualize where spikes in your application's performance happen. Use Deep Profiler to get more information about each piece of your program. For example, I have a for loop in the update function that runs multiple tasks. In Profiler, I can find the class and function and then see the milliseconds it needs to run. There is a memory profiler that you should install from PackageManager. Memory profiling is useful for testing against target hardware memory limitations. It's also a great tool if you want to improve CPU and GPU performance of your Unity game by making changes that actually increase memory usage. The memory profiler is a package that adds a window to the Unity editor so you can see memory usage in your application in even greater detail. You can store and compare a snapshot to find memory leaks or see the memory layout to find memory fragmentation issues. The frame debugger lets you freeze playback for a running game on a particular frame, then view the individual draw calls used to render that frame. You can go through the rendering steps one at a time to see how the scene is constructed from its graphical element. This enables you to quickly spot what needs fixing or investigate optimization opportunity. Occlusion culling is a process that prevents Unity from performing renderer calculations for game objects that are completely hidden from view, occluded by other game objects. Every frame, cameras perform culling operations that examine the renderers in the scene and exclude cull those that do not need to be drawn. By default, cameras perform frustum culling, which excludes all renderers that do not fall within the camera's view frustum. However, frustum culling does not check whether a renderer is occluded by other game objects, and so Unity can still waste CPU and GPU time on rendering operations for renderers that are not visible in the final frame. Occlusion culling stops Unity from performing these wasted operations. Before you begin, identify all of the game objects in your scene that you would like to be static occluders and static occludes. They should be have a train or mesh renderer component, be opaque, and not move at runtime. In the inspector window, ensure that the camera's occlusion culling property is enabled. In the top menu, select Window Rendering Occlusion Culling to open the Occlusion Culling window. Select Bake tab in the bottom right hand corner of the inspector window. Press the Bake button. Unity generates the occlusion culling data, saves the data as an asset in your project, and links the assets with the current scene. Move the camera around and observe the scene view. You should see game objects disappear from view when the camera cannot see them, due to either frustum culling or occlusion culling. If required, tweak the bake settings in the Bake tab of the occlusion culling window and repeat the baking process. Use the Unity Package Manager to select Cinemachine for installation. Cinemachine speeds up game development. It frees your team from expensive camera logic development. From first-person shooter to follow camera, from 2D to 3D, from real-time play to cutscene. Go to GameObject, Cinemachine, and create a virtual camera. This will add a Cinemachine brain to the main camera. Now the virtual camera controls our camera. You can set follow to the player and set body to third person follow. Aim to do nothing. Also you can create some noise for camera movement. Damping is how responsively the camera tracks the target. You can set the camera to collide with obstacles and set up other settings. Simply we created a third-person camera for our player. Cinemachine has a lot of features and you can find nice tutorials on the internet. A draw call tells the graphics API what to draw and how to draw it. Each draw call contains all the information the graphics API needs to draw on the screen, such as information about textures, shaders, and buffers. To prepare for a draw call, the CPU sets up resources and changes internal settings on the GPU. These settings are collectively called the render state. Changes to the render state, such as switching to a different material, are the most resource-intensive operations the graphics API performs. Because render state changes are resource intensive, it is important to optimize them. The main way to optimize render state changes is to reduce the number of them. There are several methods you can use in Unity to optimize and reduce draw calls and render state changes. GPU instancing. Render multiple copies of the same mesh at the same time. GPU instancing is useful for drawing geometry that appears multiple times in a scene. For example, trees or bushes. Static batching combine meshes of static objects in advance. Unity sends the combined data to the GPU but renders each mesh in the combination individually. Unity can still call the meshes individually, but each draw call is less resource intensive since the states of the data never changes. Dynamic batching transforms mesh vertices on the CPU, groups vertices that share the same configuration, and renders them in one draw call. Vertices share the same configuration if they store the same number and type of the attributes, for example position and normal. Manually combining meshes. Manually combine multiple meshes into a single mesh using the mesh.combineMeshes function. Unity renders the combine mesh in a single draw call instead of one draw call per mesh. Use Addressable to load and unload the data from memory. This will let you have more control over your assets that are loaded in memory. This is really important if you want to make a large game. It only loads when we ask for it. The addressable asset system allows the developer to ask for an asset via its address. Once an asset prefab is marked addressable, it generates an address that can be called from anywhere. Once the addressable assets package is installed, open the Addressables window by clicking Window Addressable Assets. Drag the item from the Project Windows Assets folder into the Addressables window tab. You can load or instantiate an asset at runtime. With addressables.load, you can load the prefab to the memory. Use load assets and use the assets label reference to load the prefab, and then if it is completed, check if it was successful, then instantiate the prefab. XR includes the following types of applications. Virtual reality, VR, the application simulates a self-contained environment around the user. Mixed reality, MR, the application combines its own environment with the user's real-world environment and allows them to interact with each other. Augmented reality, AR, the application layers content over a view of the real world. Unity supports XR development on multiple platforms and devices through its XR plugin framework. In addition, Unity provides a set of packages that add features and developer tools for building XR games and applications. Use animation rigging to create and organize a set of constraints. For example, change the rotation of the head of your player to see a target. Download animation rigging from the PackageManager. It also has great samples. A rig is a hierarchy of GameObject that use a minimum of these 4 components. Animator component, rig builder component, rig component, and constraints. To make this hierarchy available to the animation rig, the rig builder component is required. There are some constraint components, each one is useful for a purpose. For example, a multi-aim constraint rotates a game object to face its source game object. It is typically applied on a game object to follow around one or more game objects. Unity produces log files for the editor, player, package manager, licensing, development players, and hub. You can use these log files to understand where any problems happened in your application. You can access the editor logs from the console window. To do this, open a console window, Window General Console, and select Open Editor Log. If you get built for your application, the logs of the player also will be shown in console, or just go to this folder. For other platforms, Unity puts log location in a document that you can check. Changing scenes is one of the most important aspects of game development in Unity engine. Scenes management is used to organize different parts of levels of a game or application. It is mainly used for loading, unloading, and preloading scenes, menu navigation, and level restart. In your script, you can use Unity Engine.Scene Management to access the scenes. Now you can load the scene by its name or index in build settings. Use ScenesManager.LoadScene function. This function loads the new scene defined by its name in the next frame. If you want to load a scene immediately, use LoadSceneAsync. Ensure that the scenes are added to your build settings, otherwise it will give an error of can't find the scene. PlayerPrefs is a class that stores player preferences between game sessions. It can store a string, float, and integer values into the user's platform registry. Unity stores PlayerPrefs in a local registry without any encryption. Do not use PlayerPrefs data to store sensitive data. For example, we want to store the health of the player in our level and in the next level be the same as it was. If I click the F button, it will reduce the health of the player. Now we can say I finished the game and I have half of my health. If I go to the next level, you can see it reset to 100 again. So to save the number, we use PlayerPrefs.setInteger and we create a key and the value for it. Then in the next level, we check if the key exists. We will read the data and it will get the data and store it in the variable. This will save even if we close the program and enter again. This is very useful for web and Android games, but most of the time if you have a game that you don't want to be hacked easily, you should use other ways to save your game data. Unity is also compatible with writing scripts for changing the editor. Editor scripting can help you customize and extend the Unity editor to make it easier to use on your projects. For example, we can create a script and define the editor library, and then in a static function, delete the PlayerPrefs in our game. Then you can use menu item and the path you desire. Now in Tools, there is a Delete PlayerPrefs button that if I click on it, will run the function I wrote. Remember that you have to place the script in an editor folder. Otherwise, when you want to build your app, it will give you an error. Localization is adapting a game or application to meet a specific target audience's language, culture, and other requirements. Unity's localization support make it easier for game developers to create games appealing to players worldwide. Localization is essential for game developers because it enables them to reach a broader audience. Click on Window, PackageManager, and install localization. This system includes several key features: localization text, audio localization, image localization, platform integration, real-time updates. The localization settings inspector window is the access point for all things localization based. It provides an interface to access the project locals and access tables for the project. To access the localization settings, navigate to Edit, Project Settings, Localization. If no settings access exists, then click on Create. A local represents a language and region. It can also contain additional information such as currency, calendar, and user-added custom data. To create a local, click on Local Generator. To select a local, tick the checkbox next to its name. Once you have selected the locals you want, click the Create Locals button. To open the Access Tables window, navigate to Window, Access Management, Localization Tables. An access table is responsible for returning an access when requested via a key. In an access table, one column contains the key and the other column or columns contain the access for a selected local. Set the type to Access Table Collect and type the table name as you want and click on Create. Then add a key and select the object values according to each local. Now you are all set to use localization in your project. Add TextMesh Pro text to the scene, click on 3 dots and select Localize. Then set a string reference. Now you can change the localization runtime. Often when you start developing a game, you want a trimmed down version of an environment where you can move your characters around. ProBuilder allows you to quickly create and prototype 3D levels, as well as create basic 3D models without leaving Unity. To start, download the ProBuilder package. To do so, go to Window PackageManager. Switch packages to Unity registry, search for ProBuilder and click Install. In the top toolbar, click Tools, ProBuilder and ProBuilder Window. Dock the ProBuilder window wherever you want. You are all set to explore the different features of ProBuilder. Let's begin with New Shape. The New Shape feature allows you to create 12 different primitive shapes. The 4 buttons at the top of the Scene panel are used to switch between the following 4 selection modes: Object Selection, Vertex Selection, Edge Selection, and Face Selection. There are certain operations that you can perform on your 3D object to help you create the shape that you want to achieve. Flipping normal, extrusion, bevel. The Unity Audio Mixer allows you to mix various audio sources, apply effects to them, and perform mastering. The window displays the audio mixer, which is basically a tree of audio mixer groups. An audio mixer group is essentially a mix of audio, a signal chain that allows you to apply volume and pitch. It allows you to insert effects that process the audio signal and change the parameters of the effects. You can create one or more audio mixers and have more than one active at any time. An audio mixer always contains a master group. With snapshots can capture the settings of all the parameters in a group as a snapshot. If you create a list of snapshots, you can then transition between them in gameplay to create different moods or themes. You can add effects to each group or even individual audio source. The Physics Manager lets you provide global settings for 3D physics. Edit Project Settings Physics. There is also a manager for 2D physics. For example, you can change the overall gravity for the RigidBody component, or use the default physics material that will be used if none has been assigned to an individual collider. The physics material is used to adjust the friction and bouncing effects of colliding objects. To create a physics material, select Assets, Create Physics Material from the menu bar. Then drag the physics material from the project view onto a collider in the scene. Define how bouncy the surface is in Physics Manager and other settings that you can check out in the Unity document. Layer collision matrix is one of the important in here. Define how the layer-based collision detection system behaves. Select which layers on the collision matrix interact with the other layers by checking them. So for example, I can define the player and wall don't have to collide with each other. Standard materials from built-in project can upgrade to URP or HDRP automatically. So for example, in URP, if you have a standard lead shader, you can go to Windows, Rendering, and open Render Pipeline Converter. Here you can select the settings or material or even animations and then initialize it and then convert it. Any materials in a scene that use a custom shader, when you upgrade a project to use URP, turn pink to indicate the material no longer works. To fix this, upgrade the shader manually or change the materials shader to one that is compatible with URP. Unity does have tutorials for upgrade custom shaders for URP and HDRP. You can find them in their documentation. Also for the HDRP project, go to Windows, Rendering, HDRP Wizard, and then choose to upgrade the project materials. Sometimes you have two or more scripts and you store some references in the awake function, but because of the order of execution, the script can't find the reference because it still has not been created. So use the script execution order settings to specify the relative order that Unity invokes the event functions of different monobehavior classes. You can adjust the script execution order in the project settings inspector. Go to edit project settings and then select the script execution order category. In the script execution order window, you can add scripts and assign them a priority value. You can also use the attributes in your script and it will do the exact same thing if you add them through the project settings. After building your app, you can get the report files. You click on console and here you can open the player log. If you search for build size report, you can find how much each aspect of your game takes space. Also, there is a new package called Build Report Inspector, which is still a preview package. The Build Report Inspector can show the following data: the different steps involved in making your build, how long they took, and what messages were printed during those steps. A list of all assets which are used in the build and how much they contribute to your build size. A list of all files written by the build. Game optimizing is not only about writing better code. When it comes to optimization, the profiler is your best friend. Always profile your games on the platform you are creating, especially mobile games. I give some fast hints for optimization, then if you want to search to get a full description of each of them. Unity Assets Store is such a great place to learn and get assets that you don't have to put hundreds of hours to make them. Unity technology does have free assets for learning and understanding how projects are made. Use this big store for your project. The best book I would recommend for you is Unity eBooks. All of them are free and they contain super useful information, targeting all aspects of video games. Thanks for watching. I hope I have given you a general idea of game development. You don't have to know everything in depth, but it's good to at least know the fundamentals and features. Then you can easily search for those things and find tons of great tutorials. This was the first video that I put time into creating a tutorial for absolute beginners. It took almost more than 500 hours to make it, and I would be happy if you like and subscribe to see my future videos. Thanks, bye.